All right. So as we look at number 60, it's the integral from 1 to 2 of 2x times e to the x squared dx. Okay, so literally we do the exact same thing that we've been doing if I didn't have that 1 to 2 range in there. So I've got to take the integral of this. I got to use some u substitution. So I'm going to let u be x squared. Again, I'm solving this the exact same that we've been solving these. So this is 2x. dx equals 1 over 2x du. So nothing about that is any different from what we've been doing, past 2 weeks or so? Okay? So now we're gonna try to plug this stuff back in. All right, gonna substitute everything back in like we said. So you got 2x times e to the u times, instead of dx, you have 1 over 2x du. Nicely done there. We get something to cancel, don't we? The 2x's will cancel. It was very nicely done. So this is now, all right, the integral of e to the u is just e to the u. So we're going to evaluate e to the u. Okay, sometimes you write this evaluation with a one-sided bracket right here, from 1 to 2. All right. So I'm going to plug back in for my u. Okay, so that's e to the x squared from 1 to 2. Okay, and remember, this is my a, 2 is my b. We're always going to follow the pattern f of b minus f of a. Okay? So, let's start this thing out. You have e to the 2 squared minus e to the 1 squared. Correct? So you get e to the 4th minus e to the 1st, or just e. And that will be our answer. So we've got dt over t plus 7 squared. All right. Now, I always want that dt to be to the side, so I'm just going to move that dt out to the side like that. And you just have a 1, understood 1 in the top. Okay, so I'm just kind of cleaning up my integral before I even write it down to save myself some time. All right, now, I'm going to let my u be the stuff in parentheses. So t plus 7. So when you take du dt, don't we get 1? And that would give us that dt is just 1 over 1, which is 1 du. All right. So we have this integral from 1 to 3 of 1 over u squared times 1 du, which we're good with. Okay, so 1 over u squared, isn't that just like u to the negative 2 power? Mm-hmm. So we have the integral from 1 to 3 of u to the negative 2 power du. So again, let's take that integral. So negative 2 plus 1 all over negative 2 plus 1. So wouldn't that be u to the negative 1 over negative 1? Okay, evaluating that from 1 to 3. But that kind of looks bad, right? I don't want negative exponents. So wouldn't that just be negative 1 over u from the integral from 1 to 3? I think it would. All right, 68. So right here, now we got to substitute back in for our u. So this is really negative 1 over t plus 7. Okay. So all I did now is I just plugged my u back in the bottom. So my t plus 7 from my u up here, all right, is now all that I got to plug in. So we just plug those numbers in. Okay, f of b minus f of a. So this becomes negative 1 over 3 plus 7 minus negative 1 over 1 plus 7. Okay, so what is that? Negative 1 over 10 plus 1 over 8? Is that correct? Okay, so now you got to get some common denominators. Easiest thing to do, I would say, is just say that 80 is a common denominator. You could do 40. That would leave you with no simplification at the bottom. So let's do 40. So that's negative 4 over 40 plus what? 5 over 40? And so this one is 1 over 40. So the area under the curve of that graph from 1 to 3 is going to be 1 over 40. Okay, that's the area under the curve for that graph. Okay? Now, let's try this one right here. So you solve it the same exact way that you've been solving them. So this should be x to the 4th over 4, because 3 plus 1 over 3 plus 1. And then 1 plus 1 over 1 plus 1, so that's 5x squared over 2. All right. Plus c. So now you have this from negative 1 to 3. Okay, so we got to plug some stuff in. So I'm going to have 2 parts in each of the. I'm going to plug 3 into both parts. So I got 3 to the 4th power over 4 plus 5 times 3 squared. Can I go ahead and say 5 times 9?
No.
All right, over 2. Sorry, I'm going to do that. All right, minus.
Just keep going.
Okay. Minus, now we're going to plug in that negative 1. All right. So I got negative 1 to the 4th all over 4 plus 5 times negative 1 squared all over 2. Okay, so we got to do some fraction simplification in here. All right. 3 to the 4th power, 3 times 3 times 3 times 3. All right. Isn't that like 9 times 9?
I mean, if you say so.
Well, I mean, think about it. 3 times 3 and another 3 times 3. Okay, you got 81 over 4 plus 45 over 2 minus, you got 1 over 4 plus 5 over 2. Correct? Yes, no, maybe?
Yeah.
No? Yes.
All right.
Collect like terms.
Now,
I mean, not, you know.
you could do that. So we could either get common denominators right now, or we could do some like term stuff. I'm going to go ahead and distribute the negative through. So this becomes plus negative 1/4 minus 5/2. Let's see if that actually helps us. I think that it will. It might make it easier for us. 81 over 4 minus 1 over 4 is 80 over 4. Correct? All right. Plus 40 over 2. 45 minus 5 is 40 over 2. Is that right? Okay. So what is that? What is 80 over 4? 20. So that's 20 plus 20, which is 40. Okay, 40. All right, now we're going to plug in. Okay, so we're gonna plug in 2/3. You got the square root of 4 to the 3rd, because 2 plus 2 is 4. to the third power
A little bit.
minus 2 over 3 square root of 1 to the third. Because negative 1 plus 2 is just 1 to the third. Okay? So that's 2 over 3. 4 to the third power is what? 4 times 4 times 4? So is that 64?
Yes. If you say so.
It's something that gets you 16.
Minus 2 over 3 square root of 1. All right, well, look, this actually turns out pretty nice.
Yes, sir, it does.
2 over 3 times 8 minus 2 over 3 times 1. So you have 16 over 3 minus 2 over 3. So you get a nice, pretty answer of 14 over 3. So that's the area under the curve of that function.
You got negative or something, but I know you did.
Okay. Here's y'all's homework. All right, so if you forget the homework, go back and watch the video and it'll tell you. Okay, page 16 in your packet. So a couple of pages back, actually. Numbers 19, 20, and 21. Remember I told you we were going to come back to those that we didn't do? Okay. And lastly, page 18.
Hold on, wait, page 16 on
Page 18, number 13, 14, and 15.